Some of the most futuristic machines ever imagined weren't designed for the future. They were designed decades ago. A nuclear-powered spacecraft. An aircraft that still holds speed records today. And machines so unusual that they seem impossible even by modern standards. These projects were real. And they were far ahead of their time. Today, we'll take a look at some of the most incredible machines ever built, how they worked, why they were created, and why some of them disappeared. I also have a Telegram channel if you'd like to follow along. The link is in the description. The Antikythera Mechanism. In 1901, a group of sponge divers was exploring a shipwreck near the Greek island of Antikythera, when they discovered a collection of ancient artifacts on the seabed. Among the statues and pieces of pottery was a heavily corroded lump of bronze. At first, nobody thought it was particularly important. But when researchers began examining it more closely, they noticed something unexpected. Inside the object were gears. Lots of them. Over the following decades, scientists used X-rays and advanced imaging techniques to study the mechanism. They eventually discovered that it contained more than 30 interlocking bronze gears, all precisely designed and manufactured. Researchers believe the device was built sometime between 150 and 100 BC, making it more than 2,000 years old. But what made the mechanism extraordinary wasn't its age. It was what it could do. By turning a small hand crank, the machine could calculate the movements of the sun, the moon, and several planets. It could predict solar and lunar eclipses. It could track astronomical cycles and even estimate the dates of important events in the ancient Greek calendar. Some of its gears were so complex that nothing with a similar level of mechanical engineering would appear again for well over 1,000 years. In many ways, the mechanism functioned like an analog computer. The level of precision required to manufacture it has continued to surprise engineers and historians alike. Even today, researchers are still studying the device and debating exactly how it was used and who built it. What began as a corroded piece of bronze recovered from a shipwreck turned out to be one of the most remarkable machines ever discovered from the ancient world. The SR-71 Blackbird. The SR-71 Blackbird is one of the most extraordinary aircraft ever built. Its story began during the Cold War. In the late 1950s and early 1960s, the United States needed an aircraft capable of gathering intelligence deep inside hostile territory while avoiding interception. The project was developed by Lockheed's Secret Division, better known as the Skunk Works, under the leadership of legendary aircraft designer Clarence "Kelly" Johnson. The State Route 71 first flew on December 22, 1964, and officially entered service in 1966. At first glance, the aircraft already looked futuristic. But its capabilities were even more impressive. The Blackbird could fly above 85,000 feet, or about 26 kilometers, and exceed Mach 3, which is more than 3 times the speed of sound. At those speeds, the aircraft encountered a problem that most airplanes never experience. Air friction generated so much heat that parts of the aircraft reached temperatures of more than 500 degrees Fahrenheit, or around 260 degrees Celsius. Engineers had to build much of the aircraft using titanium because conventional materials could not withstand those temperatures. Even more remarkably, the aircraft physically expanded during flight. On the ground, sections of the fuselage were intentionally built with small gaps. The aircraft actually leaked fuel while sitting on the runway because its structure was designed to seal properly only after it heated up and expanded at high speed. The engines were equally unusual. At cruising speed, much of the thrust came from the aircraft's inlet system rather than from the engine cores themselves, making the Blackbird function partly like a jet and partly like a ramjet. During its operational career, the State Route 71 flew thousands of reconnaissance missions around the world. Despite operating in some of the most heavily defended airspaces on Earth, no State Route 71 was ever lost to enemy action. Whenever a missile launch was detected, the aircraft's crew often relied on a surprisingly simple response. They accelerated. Decades after its retirement, the State Route 71 still holds the official airspeed record for a manned air-breathing aircraft, reaching more than Mach 3.3, or over 2,200 miles per hour. More than half a century after its first flight, the Blackbird still looks like a machine built for the future rather than the 1960s. Concorde. Concorde was one of the most ambitious passenger aircraft ever built. Its origins can be traced back to the 1950s, when both Britain and France began exploring the possibility of commercial supersonic flight. Rather than competing against each other, the two countries decided to work together. In 1962, they signed an agreement to jointly develop what would become Concorde. The aircraft made its first flight on March 2, 1969, and entered commercial service in 1976. At the time, nothing else in commercial aviation came close to its capabilities. Concorde could cruise at Mach 2.04, or more than twice the speed of sound, reaching speeds of around 1,350 miles per hour, or about 2,180 kilometers per hour. It could fly at an altitude of around 60,000 feet, nearly twice as high as most commercial airliners. At that altitude, passengers could actually see the curvature of the Earth and the dark blue color of the sky above them. The aircraft's nose was also unusual. Because of its long, pointed shape, pilots had limited visibility during takeoff and landing. Engineers solved this problem by designing a droop nose that could tilt downward for better visibility and then raise again during flight. Concorde was powered by 4 Rolls-Royce and Snecma Olympus engines equipped with afterburners, a feature normally found on military aircraft rather than passenger jets. The aircraft was so fast that it could cross the Atlantic Ocean in about 3 hours. A flight from London to New York often took less than half the time required by conventional airliners. Flying on Concorde quickly became a symbol of luxury and prestige. Celebrities, business executives, and world leaders regularly traveled aboard the aircraft. However, operating Concorde was extremely expensive. It consumed enormous amounts of fuel, carried relatively few passengers, and required highly specialized maintenance. Its sonic boom also prevented it from flying at supersonic speeds over most populated areas, significantly limiting where it could operate. In 2000, another challenge emerged when Air France Flight 4590 crashed shortly after takeoff from Paris. Although modifications were made and the aircraft returned to service, passenger demand never fully recovered. Concorde was officially retired in 2003. Even today, more than 20 years after its final flight, no commercial passenger aircraft has replaced it. In some ways, modern air travel is actually slower than it was during the era of Concorde. The Soviet Ekranoplan. The Soviet Ekranoplan is one of the strangest machines ever built. At first glance, it looks like an airplane. But technically, it wasn't an airplane at all. It also wasn't a ship. Instead, it was a completely different type of vehicle designed to fly just a few meters above the surface of the water. The idea began in the Soviet Union during the 1960s. The project was led by Soviet engineer Rostislav Alexeyev, who had already become famous for designing high-speed hydrofoils. Alexeyev believed that by flying extremely close to the water, a vehicle could take advantage of something called the ground effect. As air becomes trapped between the wings and the surface below, lift increases and drag decreases, allowing the vehicle to carry enormous amounts of weight more efficiently than a conventional aircraft. The Soviet government became interested in the concept because it offered several military advantages. An Ekranoplan could travel much faster than a ship while remaining low enough to avoid many radar systems. It could also carry heavy equipment, troops, and missiles across vast distances. The most famous model was the Lewin-class Ekranoplan. Completed in the 1980s, the machine was approximately 74 meters, or 243 feet, long and weighed around 400 tons. It was powered by 8 massive jet engines mounted near the front of the vehicle. The Lewin class could reach speeds of around 550 kilometers per hour, or approximately 340 miles per hour. For comparison, that was several times faster than most military ships. It also carried 6 enormous anti-ship missiles mounted on top of its fuselage. Because of its unusual appearance and enormous size, Western intelligence agencies nicknamed one of the earlier prototypes the Caspian Sea Monster, after it was spotted in satellite photographs over the Caspian Sea. At the time, many analysts had no idea what they were looking at. Despite its impressive capabilities, the Ekranoplan also had limitations. It could not fly at high altitude like an airplane and generally operated only a few meters above the water. Rough seas and difficult weather conditions also created significant challenges. After the collapse of the Soviet Union, funding for the program gradually disappeared. Most of the projects were abandoned, and only a small number of vehicles were ever built. Even today, the Soviet Ekranoplan remains one of the most unusual transportation concepts ever put into operation. A giant missile-carrying machine that flew above the ocean like an airplane, but technically wasn't an airplane at all. Project Orion. Project Orion may be one of the most ambitious spacecraft concepts ever seriously proposed. The idea was born in the late 1950s during the early years of the space age. At the time, engineers were searching for ways to travel far beyond Earth's orbit. Chemical rockets worked, but they had limitations. They carried relatively little payload and required enormous amounts of fuel. A group of scientists, including physicist Freeman Dyson and engineer Theodore Taylor, believed there might be another solution. Their proposal sounded almost impossible. Instead of using conventional rocket engines, they suggested powering a spacecraft with nuclear explosions. The concept was surprisingly simple in theory. Small nuclear devices would be ejected behind the spacecraft one at a time. Each explosion would strike a massive steel plate mounted at the rear of the vehicle. Shock absorbers would then reduce the force of the blast and gradually transfer the energy to the spacecraft. The process would repeat hundreds or even thousands of times, continuously accelerating the vehicle. The numbers involved were extraordinary. Some proposed versions of Orion could have weighed several thousand tons. Others were designed to carry hundreds of people. The largest concepts were so enormous that they resembled flying cities rather than spacecraft. According to calculations, an Orion spacecraft could potentially reach Mars in only a few weeks. Some studies suggested missions to Saturn could become practical. Others proposed using Orion for deep space exploration far beyond anything possible with conventional rockets. Perhaps the most remarkable part of the project is that the physics actually worked. Engineers built small-scale models and conducted conventional explosive tests to study the concept. The calculations repeatedly showed that a nuclear pulse propulsion system could function. The main problem was not engineering. It was everything else. Launching a spacecraft by detonating hundreds of nuclear devices would release radioactive material into Earth's atmosphere. There were also obvious political and environmental concerns. In 1963, the Partial Nuclear Test Ban Treaty prohibited nuclear explosions in space, underwater, and in the atmosphere. Project Orion effectively came to an end. Even today, many aerospace engineers consider it one of the most powerful spacecraft concepts ever designed. A machine intended to reach other planets by riding a controlled series of nuclear explosions. The Horten Ho 229. The Horten Ho 229 was one of the most unusual aircraft ever designed during World War II. Its story began in Germany in the early 1940s. At the time, the German Air Force wanted a new aircraft capable of carrying a bomb load of 1,000 kilograms, flying more than 1,000 kilometers, and reaching speeds of around 1,000 kilometers per hour. The requirement became known as the 3x1000 project. Two German aircraft designers, brothers Walter and Raymar Horten, believed they had the answer. Instead of building a conventional airplane with a fuselage and tail, they proposed something radically different. Their design was a flying wing. Nearly the entire aircraft consisted of one large wing with the cockpit and engines integrated directly into it. The concept offered several advantages. By eliminating many external surfaces, the aircraft produced less drag and could potentially achieve higher speeds and better fuel efficiency than traditional airplanes. The Ho 229 was also powered by two Junkers Jumo 004 turbojet engines, the same type of engines used in some of the world's first operational jet fighters. At a time when propeller-driven aircraft still dominated the skies, the Horten brothers were designing a jet-powered flying wing. The first prototype took to the air in 1944. Test flights demonstrated impressive performance, and the aircraft showed significant potential. But decades later, another aspect of the design attracted attention. Some researchers suggested that the aircraft's shape may have unintentionally reduced its radar signature. The smooth flying wing design reflected less radar energy than many conventional aircraft of the period. According to studies conducted many years later, the Ho 229 may have been more difficult to detect than other World War II aircraft, although it would not have been invisible to radar. This led many people to describe the Ho 229 as one of the earliest examples of stealth aircraft design. However, the aircraft never reached operational service. As the war turned against Germany, resources became increasingly scarce. Factories were bombed, production slowed, and the project was eventually abandoned. When American forces advanced into Germany in 1945, they captured one of the nearly completed prototypes before it could ever enter combat. Today, many aviation historians consider the Horten Ho 229 one of the most advanced aircraft concepts of the Second World War. A jet-powered flying wing that looked more like a modern stealth bomber than an airplane designed in the 1940s. Lockheed CL-1201. The Lockheed CL-1201 may be one of the largest aircraft concepts ever seriously proposed. The project was developed by Lockheed during the late 1960s as engineers explored ideas for extremely long-endurance aircraft. At the center of the concept was something almost unbelievable. The aircraft would be powered by a nuclear reactor. The idea behind the project was simple in theory. Conventional aircraft are limited by fuel. A nuclear-powered aircraft, however, could potentially remain airborne for weeks at a time without refueling. The proposed machine was absolutely enormous. According to Lockheed's designs, the CL-1201 would have had a wingspan of approximately 1,120 feet, or around 341 meters. For comparison, that is more than twice the wingspan of a Boeing 747. The aircraft itself was expected to weigh several thousand tons. Some versions of the design were intended to carry hundreds of crew members and support personnel. Engineers even proposed building living quarters, work areas, and recreational spaces inside the aircraft because missions could last for weeks. Several versions of the CL-1201 were studied. One proposal envisioned a giant military transport capable of carrying troops and equipment almost anywhere in the world without landing. Another version was designed as an airborne launch platform capable of deploying dozens of smaller fighter aircraft. The aircraft's size was so extreme that some concepts included detachable aircraft that could leave the CL-1201, complete their missions, and later return to the giant flying base. The nuclear reactor itself presented enormous engineering challenges. The crew would require extensive radiation shielding, which dramatically increased the aircraft's weight. Engineers also had to consider what would happen in the event of an accident. A crash involving a flying nuclear reactor could have catastrophic environmental consequences. The project never advanced beyond the concept stage. The technical difficulties were immense, the costs were extraordinary, and the risks associated with operating a nuclear-powered aircraft proved difficult to justify. Even so, the fact that engineers seriously studied the idea remains remarkable. The Lockheed CL-1201 was essentially a proposal for a flying city powered by a nuclear reactor and capable of staying in the sky for weeks at a time. Sea Shadow. The Sea Shadow, officially designated 9-529, is one of the strangest naval vessels ever built. At first glance, it doesn't even look like a ship. Its sharp angles and unusual shape make it resemble something from a science fiction movie. The project began during the Cold War. In the early 1980s, the United States Navy became increasingly interested in stealth technology. Aircraft such as the F-117 Nighthawk were proving that specially designed shapes could dramatically reduce radar detection. The Navy wanted to know whether the same idea could work at sea. To answer that question, the Defense Advanced Research Projects Agency, better known as DARPA, and Lockheed's famous Skunk Works division began developing an experimental stealth ship. Construction of the vessel started in the early 1980s, and the Sea Shadow was launched in 1984. The ship was approximately 164 feet, or about 50 meters, long and was built using a unique SWAT design, which stands for Small Waterplane Area Twin Hull. Instead of using a conventional hull, the vessel rested on two submerged pontoons connected to the main body by narrow supports. This configuration significantly improved stability in rough seas. But the most remarkable feature was its shape. Nearly every surface on the ship was angled. There were very few vertical walls and almost no right angles. The design helped scatter radar waves away from their source, making the vessel far more difficult to detect than conventional ships. The Sea Shadow also used extensive automation. At a time when many warships required large crews, this experimental vessel could operate with only a small number of personnel on board. For years, the project remained highly secretive. The ship was usually hidden inside a giant covered barge whenever it was transported or not being tested. Many people had no idea the vessel even existed. When photographs of the Sea Shadow eventually became public, its appearance surprised both military experts and the general public. It looked less like a ship from the 1980s and more like something designed decades in the future. Despite successfully demonstrating many stealth concepts, the Sea Shadow never entered mass production. Building large stealth ships proved expensive, and some of its technologies were eventually incorporated into other naval programs instead. Even so, the Sea Shadow achieved exactly what it was designed to do. It proved that a warship could be built with stealth as one of its primary features. A vessel that looked futuristic even in its own time and helped shape the development of modern naval technology. XB-70 Valkyrie. The XB-70 Valkyrie is one of the most extraordinary aircraft ever built. Even today, more than half a century after its first flight, it still looks like a machine from the future. Its story began during the Cold War. In the 1950s, the United States Air Force wanted a strategic bomber that could fly higher and faster than anything ever built. The aircraft's mission was simple in theory but incredibly difficult in practice. It needed to carry nuclear weapons deep into enemy territory, travel across continents without refueling, and be so fast that enemy defenses would struggle to intercept it. Several companies proposed designs, but North American Aviation won the contract. What they created was unlike anything the world had ever seen. The XB-70 was enormous. The aircraft measured nearly 185 feet, or about 56 meters, in length and had a wingspan of more than 105 feet, or approximately 32 meters. It was powered by 6 massive General Electric turbojet engines mounted in a single engine compartment beneath the rear of the aircraft. Its performance targets sounded almost impossible. The bomber was designed to cruise at Mach 3, more than 3 times the speed of sound, while flying above 70,000 feet, or around 21 kilometers. At those speeds and altitudes, many fighter aircraft and missile systems of the time would have struggled to reach it. But speed created entirely new engineering problems. At Mach 3, air friction generated enormous amounts of heat. Large sections of the aircraft became so hot that engineers could not rely on traditional aluminum construction. Instead, the XB-70 used extensive amounts of stainless steel and titanium, materials capable of surviving the extreme temperatures generated during sustained high-speed flight. Some parts of the aircraft's skin reached temperatures exceeding 600 degrees Fahrenheit, or around 315 degrees Celsius. The aircraft also featured one of the most unusual wing designs ever put on a bomber. At high speeds, the outer portions of its wingtips could fold downward. This created a phenomenon known as compression lift. Shock waves generated by the aircraft's own supersonic flight became trapped beneath the wings, effectively helping support the enormous bomber and improving both stability and efficiency. Few aircraft in history have ever used this concept so extensively. The Valkyrie was also designed with an advanced variable air intake system. At Mach 3, the engines could not simply absorb incoming air directly. The aircraft had to carefully slow and compress the airflow before it reached the engines. Managing these conditions required extremely sophisticated engineering and control systems, especially for the late 1950s and early 1960s. The first XB-70 prototype took to the air on September 21, 1964. Test flights demonstrated extraordinary performance. The aircraft successfully exceeded Mach 3 and became one of the fastest and highest-flying aircraft ever built. However, while the Valkyrie was being developed, military technology was changing rapidly. Intercontinental ballistic missiles were becoming increasingly important, and advances in surface-to-air missiles raised new concerns about the survivability of large strategic bombers. At the same time, the aircraft's costs continued to rise. Each prototype represented an extraordinary investment in engineering and technology. Ultimately, only 2 XB-70 prototypes were completed. In 1966, one of them was destroyed in a mid-air collision during a publicity photo flight. The accident claimed the life of legendary test pilot Joe Walker and seriously injured Valkyrie pilot L. White, who managed to eject and survive. The second aircraft continued flying as a research platform, helping scientists study high-speed aerodynamics, materials, and supersonic flight. Even though the XB-70 never entered operational service, its influence continued for decades. Data collected from the program contributed to future high-speed aircraft research and expanded engineers' understanding of sustained supersonic flight. Even today, the Valkyrie remains one of the most ambitious aircraft ever built. A 6-engine bomber capable of cruising at 3 times the speed of sound and using its own shock waves to help keep itself in the air. These machines may have been built decades ago, but many of them still feel futuristic even today. Some changed entire industries. Some never made it beyond the prototype stage. And some were simply too ambitious for the technology and circumstances of their time. If you enjoyed the video, feel free to subscribe. I genuinely appreciate your support. I also have a Telegram channel if you'd like to join. The link is in the description. Until next time.